quantity, and the order day from the orders table, where the user ID equals the user ID corresponding to the user that logged in, and the order month equals 10, if, say, the user wanted to see what pizzas were ordered in the month of October. Of course, an attacker has many options to still attack. What the attacker can do is choose 0 or 1 equals 1 to be the order month. So, the attacker can just download the HTML, modify the value to be or equals 1 over 1, correct some things in the form, and resubmit it to the website. Now, what happens when this input gets submitted is the query will be as before, except at the end it'll say where user ID equals 4123 and order month equals the order month provided by the user, 0 or 1 equals 1. So, of course, in SQL, AND takes precedence over OR, and so the user ID equals 4123 and order month equals 0 ends up evaluating to false, but the OR 1 equals 1 part evaluates to true. And notice that there's no user ID specified. So basically, the result of the query will be all of the pizzas that were ordered for every user. So if an attacker entered 0 or 1 equals 1, the output that the attacker would get is a table as follows, which contains all of the pizzas, all the toppings, all the quantity, all the order days for all the pizzas that were ordered for all the users. Now, while this might not seem that bad for a site that allows you to order pizzas, imagine if this was a web service that allowed you to store your medical history, or if it had a lot of credit card numbers behind it. Well, this could be quite damaging. It basically allows the attacker to get all user data. In fact, let me provide just one more example here. So let's say, it is a pizza delivery site, and I simply want to get access to all the credit card numbers that were used by legitimate users. Well, what I could do as an attacker is, for the order month parameter, I could provide the input 0 and 1 equals 0, union select cardholder number, expiration month, expiration year from the credit cards table. So what's going on here? Well, the 0 and 1 equals 0 will end up evaluating to false. And so basically the entire first part of the query evaluates to false and returns no results. But the union select cardholder number, expiration month, expiration year from credit cards will give back all of the credit card information for all the users on the site. Why does this attack work? Well, if you notice, in this particular example, cardholder number, expiration month, and expiration year, if you look at the types of those columns, the data types, they are chosen to exactly match the data types from the previous query. So the union actually works. And what the attacker will get as a set of output is the following. They will get the pizza order history table with the values corresponding to the credit card holders' names, the numbers, the expiration dates, and the expiration years. By the way, I should mention, while I've been demonstrating these attacks, you should not try these attacks on real sites for the reason that they may very well work, and we don't want you to get in trouble. And I certainly don't want you to get me in trouble for having told you about how these attacks work. So, where should you try these types of attacks? You should use them on test versions of, say, websites that you're developing for yourself, or let's say you're working for a company. Use them on a test version of your company's site. Don't even try it on the production version, because again, it might work, and then you'll see all this information. And if your company has to abide by SOX regulations, you might have just violated the SOX regulations by having engineers look at the actual data. So this is an example of a SQL injection attack. And now that I've told you about the attack, let me tell you a little bit about how you prevent these kinds of things. So we've seen that in this previous attack, let me just go ahead and go back for a second. In this previous attack, the information that the attackers supplied did not have any quotes whatsoever, did not have any semicolons whatsoever. And so this is an indication that simply trying to blacklist or filter out certain characters that you think might be dangerous does not work. Instead, an approach based on whitelisting might be desirable. So first of all, because attacks are possible where the attacker doesn't need to use any special characters. Even if the attacker did use special characters, you might forget to filter out some of them and not others. Each database is different. Each of them have lots of different features. It's kind of hard to get the set right. But also, with things like quotes, there might be a user that's interested in having the username Brian. That could be a completely legitimate username. Why should you prevent the user from having that username? If your site wants to build a personal relationship with the user, you want to abide by their requirements, not your own. So blacklisting characters is generally not the best approach. Instead, an approach based on whitelisting might be better, where you can define regular expressions like the ones that I have here, and you could compare the user input to the regular expressions and only submit, say, the SQL query if the input matches one of the regular expressions. So if I'm expecting a month, I might use the second regular expression here. By the way, these are just examples. If we put in a couple minutes of thought, we could come up with much better regular expressions. Writing these kinds of regular expressions is hard. I'd encourage you to trade them with your friends and your colleagues and try to break each other's regular expressions. So using an approach based on whitelisting is better. And what you could do is, if your company or your organization is using a web application firewall like mod security, you could implement these kinds of whitelists using mod security and defend your website against these types of attacks by whitelisting. In addition to whitelisting, it might also be important for you to escape certain characters. So let's say you do want to allow the user to choose a quote as part of the input. Well, what you can do is use the database's escape functions, and each database has slightly different escape functions. So if you escape Connor, the database driver will give you back Connor, and basically the double quotes will be interpreted as a single quote data and will not be interpreted as control information. One of the running themes that you might see in attacks in the area of security is that the attackers might try to send in data that gets interpreted as control by the application, and that's absolutely a bad deal. You want to make sure that the database always interprets data as data. So another approach that you can use to prevent SQL injection attacks is taking advantage of prepared statements and bind variables. If we were to rewrite the backend a little bit differently, what one could do is have a query as follows, and call a prepare statement on a query template, where the query template basically provides the structure for the query and has question marks in places where we expect user data to get filled in. The purpose behind this is that by using these placeholders and then by later on telling the database driver, hey, set this first parameter to be the user ID, set the second parameter to be the month. If the attacker tries to specify a month that is, say, not an integer, the code will generate an exception. And the other thing that happens here is that the database will make sure to always interpret whatever you put in for the question marks as data and not control. So even if there was a quote in this input or an OR statement or whatever, it'll get interpreted as data and not a command. So that's another tool that can be used to fight SQL injection. What kinds of additional things can you do? Well, to the extent that you can, you should take a defense in depth approach. You should use as many diverse techniques as possible. One thing you could do is limit privileges. So you might not need to allow every user to be able to modify or delete data from the database. And so you could create a database user and have the web application log into the database with, say, a read-only account. So that even if someone is able to figure out a SQL injection attack, they're only able to read information but, say, not change it. Of course, as we saw in the previous example, even being able to read information can lead to very significant attacks. You should also make sure to harden your database server and your host operating system. So some databases, such as Microsoft SQL Server at some point, what it did is when the database comes to you out of the box, it has all kinds of interesting functionality turned on. It has functionality turned on that allows you to make outbound network connections. It has functionality turned on that allows you to execute command shells all from within SQL statements. But once you're launching an application into a production environment, there's no reason to keep those types of functionalities on. And in fact, it might be advisable that if your database application is using those types of functionality,